Hello guys, and welcome back to our YouTube channel. In this video we are going to dive into periodic and compound periodic functions. Okay, so let us start with the first part, which is let's start with the first part, which is the periodic function. Okay, so here, first of all, a function is periodic if it repeats its values after a constant interval t. So I'm trying to say that here f of x is equal to f of x plus t, where t is the period. So let me say it in simpler terms. A function that repeats at equal intervals is a periodic function. Okay, so a periodic function is given by this, that is f of x plus t, where t is the period. Okay, so examples of periodic functions, we have sine x, cos x, and tan x. Okay, sine x is a periodic function because it repeats after every 2 pi. So sine x is a periodic function because it repeats after 2 pi. So 2 pi is the period of sine x. Okay, cos x also repeats after every 2 pi. So the period of cos x is 2 pi, while tan x repeats after every pi. So the period of tan x is pi. So that is just a simple definition. So if we have a periodic function with period c, then our f of x is going to be f of x plus kc. So here c is any period, it's a certain period. Okay, so let me just give an example to explain whatever I'm saying here. Okay, so let's take an example. Let's say our f of x is equal to x plus 1 for minus 1 x, and f of x is equal to f into x plus 3, and we are asked to sketch a graph for y equal to f of x in the interval for minus 4, and we are to find the values f of minus 13, f of let me see, okay, let's just leave it like that, f of minus 13. Okay, so let's solve this example. So we have f of x equal to x plus 1 in this interval, and f of x is f into x plus 3. So remember, in the definition, I said given that f of x is equal to f into x plus t, t is the period. So here we have this case. So we are going to say our period is 3. So sometimes they are going to tell us what the period is. Sometimes they are going to tell us that the period is equals to 3. But if they give you anything in this form, then from here we can say that the period is 3 from the looks. Okay, so We are going to be solving this in steps. Okay, so let me give you guys the steps to solve it. So we have step 1. Step 1 is to sketch the base interval. Okay, so we have been given the interval -1 less than or equal to x less than 1 for f of x equal to x plus 1. Okay, so we cannot just sketch a graph without its coordinates. We cannot just start from anywhere. We cannot just sketch a graph without coming out with its coordinates. So from this interval and its definition, we can come out with the coordinates of our graph we are supposed to draw. Okay, so from here they say we should sketch a graph for y equal to f of x. So we are supposed to have our x and y coordinates. But for the x coordinates, we have already been given an interval. We have been told that x ranges from -1 to 1. So we have been given our interval in which our x values are supposed to come out from. And from there, we are supposed to derive our y coordinates because we are to sketch a graph of y equal to f of x. Okay, let me show you guys how we are going to do this. Okay, so let's take x equal to -1. This -1, let's take the first value of our x. So when x is equal to -1, we said y is equal to f of x. So we are going to substitute -1 into our f of x function. So we are going to have, so let's say, let me draw a table, the values. So these are our x values, these are our y values. So let's take the first one. I've said let's take the first value where x is -1. We are going to substitute it into the f of x function. So we are going to have -1 plus 1, which is equal to 0. So when x is -1, y is 0. Remember, we said we are to sketch a graph where y is equal to f of x. And we are taking our first value of x as -1 since -1 is in our range. Okay, so we are going to have that, which is 0. So when x is -1, y is 0. Okay, so in this range in which we have been given, there are many values of x in which we can derive. There are many values of x inside that range, but we are not going to take all the values. We are just simply going to take the two which we can see. We can see -1 and 1. So it ranges from -1 to 1. So we are just going to take those two. We are not going to take everything inside the range. We are just going to take only the two. So we have already had the first case where x is -1. Let's take the second case where x is 1. Okay, if we take all the values of x, if we take all the values inside this range, it's going to give us the same drawing of the graph. It's going to give us the same graph, but it's too much. So we are just going to take, why should we take all the values when we can just take these two values and have the same graph? Okay, so we have x is, when x is -1, y is 0. So let's take the next case where x is 1. So when x is 1, we substitute it into our function. We have 1 plus 1, which is equal to 2. So we have 2. So when x is 1, y is 2. Okay, we are going to end there. Okay, so let me give you guys something quick. So we have -1, 0, 1, 2. These are our coordinates, right? X, y, x, y. Okay, these coordinates -1, 0. Let's go to our range. Our range Let me just write it back. It's minus 1 less than or equal to x less than 1. So if we look closely, these coordinates fall in our interval. Minus 1 and 0. The coordinates are in our interval. So we can say it is closed. And this coordinate 1, 2. 2 is not in this interval. 2 is not in our interval. So it is an open coordinate. So a closed coordinate, to plot the graph, is going to be represented by a dot, while an open coordinate is represented by an open circle. You are going to see it as I draw the graph. Okay, so we have been told that we should sketch y equals to f of x for this interval. So we are to sketch the graph in the interval x greater than or equal to minus 4 and x less than 4. So we have been told that in our graph, this is the range of x. So we have been told how to draw the graph. So let's draw it together. Okay. Okay, so our x, we said it ranges from minus 4 to 4. So this range is just the range in which we are going to use to draw the graph. It is not the main range. It is this other range that helps us to get our coordinates. The range, the interval which has its definition, that is what we use to get our coordinates. But when we are asked to sketch a graph of y equal to f of x for this other range, they are just telling us how our graph should look like, the range of values of x in which we are to plot our graph. So we have been told that x ranges from this. So let's draw it. We have 1, 2, 3, 4. Here we have minus 1, minus 2, minus 3. Let me just extend, and we have minus 4. Okay, that is the range in which we have been given. That is what they told us. That is how they told us to design our graph for the x-axis. Okay, for the y-axis, we are going to determine the values in which we are to plot from our coordinates. So we have the coordinates minus 1, 0 and 1, 2. So from this, we can see that this x, this xy. So from here, we can see that the highest value of y in which we have there is 2. So our graph is just going to have 1, 2. Here we are going to have minus 1, minus 2. Okay, let us plot the graph. So the first coordinate is x minus 1 and y 0. So remember I told you this coordinate is closed, this is open. This coordinate is closed because these two values are in our interval. Our interval is this is our interval. So these two values are in our interval, so it is closed. So when x is minus 1, this is minus 1, and when y is 0, so this is it here. And remember I told you it is a dot. We represent it as a dot. So that is what we have there. Here we have when x is 1 and y is 2. This is x1, this is y2. So it is open because 2 is not in our interval. So we are going to have it like this. So let me just, okay, so that is what we have. Okay, so that is all, those are all our coordinates. So we are going to draw the line. We are going to link the 2 points. Okay, so that is what we have. So remember, our period here was 3, and a periodic function. Remember, I said a periodic function is a function which repeats at equal intervals. So here our period is 3. So this function repeats every after 3 units. So the function is repeating every after 3 units. So we are not going to leave this graph like this. We are going to continue the graph. We are going to repeat the graph after every 3 units. We are going to have the same graph. After every 3 units, we will have the same graph. So that takes us to our next step. So that was step 1. Step 1 was just to sketch the graph. So step 2 is to extend periodically. Okay, so remember, the period is 3 and periodic functions repeat after their periods. So here we have 3 as our period. So this curve, this line, this shape is going to repeat every after 3 units. Okay, so let's count 3 units. This is at this point here, we are going to shift it 3 units. So we have 1, 2, 3. We mark this point. Here we are going to shift it 1, 2, 3. We mark this point. We draw our graph again. So this is 3 units. So it is repeating every after 3 units. So I could continue this graph, but it is not really necessary. So I'm just going to give you guys short and simple. So it is not only repeating in the positive direction, it is also repeating in the negative direction. So we are also going to shift it 3 units backward. So we are going to have 1, 2, 3. 1, 2, 3. So this also is 3 units. So this is what we have. So it is shifting every after 3 units. The graph shifts. In fact, the shape of our graph repeats every after 3 units. Okay, so to shift this graph, we go to this point of -1 and 0. We take it 3 units. 1, 2, 3. That is where we had this second point. This next one we had here 1, 2, and 3. So we are shifting it, and it does not shift only in the positive direction, it shifts also in the negative direction. So it repeats every after 3 units. Okay, so this is our step 2. So our step 3 is to remember, they told us that we should find f of -13. F of -13. So remember, this is what we are to find. Okay, so when we look at -13, when we look at our interval, this is our interval that we were given. -13 is not in the interval, so we cannot evaluate -13. If we had a value which was in the interval, if we had, like, for example, if we had evaluate f of 1, or let me say f of 0. If we were asked to evaluate f of 0, f of 0 is in the interval. F of 0 is in the interval. So we have that f of x is equal to f of x is equal to x plus 1. So under normal circumstances, we would just take this 0 and substitute it here. We'll just have 0 plus 1. So it's going to give us 1. That is how it is. but minus 13 is not in the interval. So we need to find ways, we need to evaluate it in order to be able to solve it. So remember, we have been given a period of 3. So our period is 3. Remember, periodic functions repeat. So we have minus 13. We have minus 13. Okay, so we are going to add 3 to minus 13 until we have a value which is in our range. This is our range. Our range is, this is our range. So since minus 13 is not in our range, is not in our interval, and we have been given that 3 is our period. So we are going to add 3 to this value. We are going to add 3 to minus 13 until it gives us a value which is in our range. Okay, so let's have this. We are going to have minus 13 plus 3. Okay, so what would that give us? It will give us minus 10. Minus 10. Is minus 10 in this range? No, it is not. We add again. Minus 10 plus 3. This will give us minus 7. Is minus 7 in the range? No, it is not. We add again. Minus 7 plus 3. Is minus 7. Okay, sorry. This is, oh, sorry. This gives us minus 4. Is minus 4 in our range? Still no. We add again. Minus 4 plus 3. Now we have minus 1. Is minus 1 in our range? Let us check. We have x less than 1, x greater than or equal to minus 1. Yes, minus 1 is in our range. So we have our value. So we can say that f of minus 13 is the same as f of minus 1. So we have broken it down. We have simplified it because we had to look for a value which was in our range. So we have seen that minus 1 is in our range. So finally, we can substitute it in our function. So our function is f of x equal to x plus 1. So we are going to substitute minus 1, which is minus 1 plus 1. It gives us 0. So this gives us 0. So f of minus 13 is equal to 0. So we had to simplify this. We had to break it down in order for us to get what we were looking for, because minus 13 was not in our range. So we had to add 3 to minus 13 until it gave us a value which was in our range. Okay, we have it like that. So that is what we have. Okay. So this is all for periodic functions. Now let us go to the second one, which is compound periodic functions. Okay, so let's go to compound periodic functions. Okay guys, so remember, in periodic functions, first we have to sketch the graph. Secondly, we extend the graph. That is, after its period, it repeats every after its period. So that is what we have. And here we had to evaluate f of minus 13, and it was not in our range. So we had to find a value which was in our range by adding the period to minus 13. Okay, so that is all for today, guys. Thanks for watching this video, and I will see you guys in the next video.